Welcome. Our goal is to learn how to partition a directed line segment. So let's kind of back up and get to the basics here. Line segment, you know what that thing is. So here's a line segment. Here's one endpoint is at A, another endpoint is at B, and this is the line segment between those two endpoints. And so we could say that it's line segment AB, or we could also say it's line segment BA, right? It doesn't matter the order that we start or that we have these endpoints in. But now they're asking, or this is a directed line segment. They're going to direct us which point to start at. So they're telling us to start at point A, and they want us to partition this directed line segment. In other words, they don't want us to go all the way to the end. Instead, they only want part. They only want part of this directed line segment. So we're going to start at A, and they want us to go a certain ratio toward from the starting point toward the ending point. This tells us find the coordinates of point P. So point P is our partition point. Here's our partition point there. Find the coordinates of point P along the directed line segment AB with A and B, so that the ratio, that's a key word for us, the ratio of AP, so AP is this guy here, the ratio of AP is, or to PB, so PB is this part up here. So the ratio of AP to PB is 2 to 3. So in other words, they're saying they want us to go 2 parts. Here they want us to travel 2 parts with 3 parts remaining. Travel 2 parts with 3 parts remaining. I meant to change that a different color. Let's do it this way. There we go. And oops, nope. And make that 3. Okay, they want us to travel 2 parts with 3 parts remaining. So how many total parts are there? How many total parts do we have here? We have 5 parts. So you see what we're doing? Now with the midpoint, right? You're familiar with midpoint. When you see midpoint, you're thinking of middle, and in that case, even if it was up going like diagonal like this, with midpoint, you want to be in the middle, halfway through. So that'd be like doing 1 to 1, or you could say 2 to 2, or 3 to 3. It's still the same number of parts at the beginning compared to the remaining parts that you have. Okay, or you could say you travel 1 part and you have a total of 2 parts, so you're only going half of the distance. So with a partition, it's different. It's not a 1-to-1 ratio. Instead, it's some kind of ratio like 2 to 3, or you could have a ratio of 2 to 1, 3 to 2, 2 to 4, all kinds of different ratios. Okay, so how do we do this? Well, let's start off by thinking about this ratio. And like we were saying, ratio is part to part. So in this case, remember we had 2 parts that we are going, and then we have 3 parts remaining. 3 parts remaining. And in order for us to do this easily, we want to convert it into a scale factor. We want to take the ratio and convert that into a scale factor. And the variable that we're going to use for scale factor is k. And scale factor is part to whole. So ratio was, you could think of it as the first part to the second part, whereas the scale factor is the first part. So we said that this was, let's go up here. So this was 2, right? The first part. So the first part would be 2, but the whole is the entire, how many total parts that we have. So remember, in this case, we had a 2 to 3. we're going to travel 2 parts and have 3 parts remaining. So the whole is going to be 5. So in this particular case, we're going to have a scale factor of 2 to 5. So when we have a ratio of 2 to 3, that's converted to a scale factor of 2 to 5. Let me also mention that here where we have, make it smaller, here you have the word 2, 2, 2, 3, the word to, that's the same thing, or we convert that to a colon. Here is a colon. So when you see this colon, think of that as the word 2. So the ratio 2 with the word 2, 3, or you could have the colon there. Okay. And then scale factor will always be a fraction, at least for our purposes, will always be a fraction bar there, where the part is on the top and the whole is underneath. Okay, so let's practice. Well, hold on. Before we do that, let me make sure that you... No. Let's practice this converting from a ratio to a scale factor. So I've done 2 of these here. Ratio, they say, they're giving us a ratio of 2 to 1, and we want to convert that to a scale factor. So remember, our scale factor is part over whole. So we take that first part is 2, and over the whole, so how many total parts do we have in this directed line segment? And it's 3. So all we're doing is just adding, taking 2 plus 3, or 2 plus 1, and that gives us the number 3. Okay, so if they give us a ratio of 2 to 1, that converts into a scale factor of 2 over 3. And if they give us a ratio of 1 to 5, that converts into a scale factor of 1 over 6. All we're doing is adding 1 plus 5, and that gives us 6. All right, so pause the video, if you would, and go ahead and do these here. Now, if you're just working on a sheet of paper, that's fine. If you don't have these notes, that's fine. Just on your sheet of paper, if you would, write this as a title on top of your sheet of paper, and then just put, well, I would recommend that you do write this stuff on your paper, okay, those kind of formulas, as it were, and then write down 1, and then go ahead and write these down as examples, and then write the rest of these down, C through F. All right, so pause the video and fill out the rest of those things on your sheet of paper. All right, let's go to number 2 now. So now that we have this figured out for ratio, tell you what, before we do that, I did want to go over here and show you what's... do I want to do that yet? No, let's not do that. Let's not do that. Okay, let's go ahead and do number 2 now. And I just want you to get a feel for what's happening. Okay, so I want you to be able to use this, to go from these coordinates and have a sense of what's happening on the graph. So here's our starting point here at 1, 5, and our ending point is 7, 9. So I just want you to have a visual picture in your mind of what you're doing when you're going from 1, 5 to 7, 9. And let's break this thing up into the x component and the y component. Because when we actually do this formula, we're going to just focus on the x and ignore the y and get the x coordinate for the partition point. And then we're going to focus in on the p and the the y coordinate, and figure out what the y coordinate of the partition point is. Okay, and then we're going to combine those x coordinate and the y coordinate together. All right, so here we go. Let's look at the x-coordinate. And of course you know that when we have a coordinate pair, it's always x comma y. So we're starting at x sub 1 is 1, and x sub 2 is 7. So when we go from 1 to 7 in the x-coordinate, first of all, what direction are we going? And we're going to the right. See, it's we're going to higher number, from a smaller number to a higher number. Therefore, we're going to the right on your x-axis. And how many steps are we going? From 1 to 7 is 6 steps. So we could do it this way. We could say 7 minus 1 gives you 6. Okay. Now let's look at, let's change the color here. Let's look at the y-coordinate. So going from 5 to 9 on the y-axis. Right, now we're thinking about the y-axis. We are going from a small number to a bigger number. So therefore we're going up on the y-axis. And we're going from 5 to 9. So we could say 9 minus 5. And that gives us 4. So when we go from a y-coordinate of 5 up to a y-coordinate of 9, we're going 4 steps up. Now a little more difficult here with our x-coordinates. When I'm going from -4 to -6, what direction am I going on that x-axis? And I'm actually going to the left, aren't I? So that's why I have a left arrow here, because think of the number line. Here is -4, and where is -6 on the number line? Here's 0. -6 is over to the left, right? So here's -6. So I'm going 2 spots, or 2 steps to the left, to go from -4 over to -6. So you could still do it as we're doing -6 minus -4. Just like here we had 7 minus 1 gives us 6. So also -6 minus 4 gives us what? How do you do that? Remember when we subtract a negative? When you subtract, you go to the left on the number line, but when you subtract a negative, you actually go to the right. So it's like a big plus sign. So -6 plus 4 would give us -2. Right? So we're going 2 to the left. Would be a way of thinking about that. Okay, let's look at now the y-coordinate. When I go from 6 to 11, I'm going from 6 up to 11, and that's I'm going up, and I'm going 5 spaces up. Okay, so you pause the video now, if you would, and write these out, C, D, E, and F, and do those on your own. Figure out the direction, and then also how many steps you're going in that direction, whether it's the X or the Y. Okay, you ready? Let's go ahead and do the next part. Again, please make sure you pause the video. Don't just copy down what I'm doing. I want you to do all the rest of this work on your own. So let me go over here. And you know that I was saying that we have a ratio of 2 to 3, right? So it's as if we started, we did 2 parts, and we had 3 parts remaining. Now maybe you noticed that, wait a second, Mr. Evans, down here, it's actually, you're going 4 steps, 4 steps, and there are 6 steps remaining. Because remember I said that we're going to break this up into 2 separate problems. We're going to look just at the x coordinate, and then just at the y coordinate. So when we look at the x coordinate for this particular problem, notice we're going 4 steps, and we have remaining 6 steps. So what's the deal with that? Wouldn't that be a ratio of 4 to 6? I thought you said we wanted a ratio of 2 to 3. And I think you're probably smart enough to realize that if I was to divide the 4 by 2, let's do it this way. Whoa, didn't mean to do that. Let's do one at a time. Yeah, so if I was to take the 4 and divide that by 2, that would give me 2. And if I was to take the 6 and also divide that by 2, that would give me 3. So you notice that 4 to 6 is the same ratio as 2 to 3. It's just it's beefed up. So all we have to do is reduce that. And the same thing when we look at the y coordinate. Here there's a ratio of 6 to 9. And so what is the common factor between 6 and 9? It'd be 3. So if I say 6 divided by 3, that's going to give me what, 2? And 9 divided by 3 is going to give me 3. So see there, I had the same ratio of, oops, it's kind of going the other way, right? Because I'm going up. Here's my starting point on the bottom, and so you can think of it on the y-coordinate. Here's my starting point on the bottom, and I'm going up. So I'm going up 6 steps, and I have 9 steps remaining, which is a ratio of 2. And so let's not do this here. Let's get rid of that. So it's not 3 over 2. It's actually 2 over 3. Because we're going from the bottom up. All right. Hopefully that's bringing some clarity to you. Now let's take this knowledge that we have so far and plug it into our equation. Nice. You can see all of it at one time. Well, I'll tell you what. Before we do that, let's do this. And let's actually kind of back up a little bit so you can see this part. Okay, maybe a little bit more. A little bit more. So I want you to be able to see the. That's good enough. I can do some more here. There. That's probably too much, but okay. So I want you to be able to see the whole thing here. Now let's back up. Okay, here we go. So here are our formulas. And first of all, remember how I said we're going to look at the x-coordinate first? So here's our formula for the x-coordinate to find the x-coordinate of the partition point. And then here's the formula to find the y-coordinate for the participation point. I'm tired. I'm not sure why it's hard for me to say participation. I want to say participation, but partition. There it is, partition point. Okay, let's get this straight here. So this is the formula to find the y-coordinate of the partition point. Okay, so notice that these are exactly the same. I mean, nearly. Here's x1 plus k times x2 minus x1. And in order to get the y version of that, all you do is just swap out the x's and put y's in them. So y1 plus k times y2 minus y1. Okay, we got it. So let's just focus in then on the x. Let's just focus in on the x, and we're going to do the same thing for the y. So x1 is our beginning point. So in this particular example, we would start at -8. So x1 is our starting point, we'll call it. And we want to add that to that starting point, we want to add what fraction of the whole. Okay, so remember this is a partitioning. So what part, you could say it that way, what part of the whole do we want? So the part is our scale factor. What fraction? Remember how like scale factor would be, well, in this case it was, what was it, 2 over 3? No, 2 over 5, right? Yeah. So we took a ratio of 2 to 3, and it turns into a scale factor of 2 to 5. So our scale factor in this particular example would be 2 over 5. Right? Yeah. So the ratio is 2 to 3, but the scale factor is 2 to 5. So we have 2/5. I only want to go 2/5 of the way of the whole. So to get the whole, notice that we do the ending point. That's your x sub 2 minus the starting point. Okay. So hopefully this formula makes sense. It's really important for you to understand formulas. For the geometry EOC coming up, you have very few formulas that they give to you. You have to memorize them, and the best way to memorize them is to understand them. So you need to understand how this formula works. Okay. So I think we're ready to zoom in now and actually do a particular problem. Okay. So here's our formula, and all we're doing is taking that down here and writing that formula. Please get in the habit when you do these problems to write the formula over and over and think about that formula as you do that. That'll help you to remember it. Okay, so let's read through our problem. Given line segment AB with endpoints A and B, what are the coordinates of point P that is partitioned? Yeah, so this is your partition point. What are the coordinates of point P that is partitioned in the ratio of 3 to 3 from A to B? Okay, so I've circled those. That's really critical information. The ratio of 3 to 3, so there's our ratio. And let me go back up here. So remember that the ratio is part to part. Okay, so ratio is part to part. So when they say 3 to 3, that's my ratio of 3 to 3. And so the first thing I want to do is convert that to a scale factor, just like we did up here. So you guys remember how to do that? So we go 3 parts. That's the 3 up on top here. And then how many total? What's the whole that we have? It's 3 plus 3, which is 6. Okay, so our scale factor is 3 over 6, and we can reduce that by looking for the greatest common factor between 3 and 6, which is 3, and it reduces down to 1/2. So that's our first step. Take that ratio and convert it into a scale factor. So now we have the scale factor of 1/2. The next step is really important, that you determine what your starting point is. In other words, the starting point will not always be A. It will not always be the first coordinate that they give you. Sometimes they'll be tricky and they'll give you a coordinate, but instead of saying from A to B, they'll say from B to A. If that was the case, it totally changes the problem. And let me explain that to you. So if our starting point was not A, but was actually B, all right? So if we started from B and still did this ratio of 2 to 3, we would go 2 parts and then stop. So this would be 2 parts here, and then we'd have 3 parts remaining. So if our starting point was B, the partition point would actually be right here. But if we start from A, the partition point is there. Okay, so it does matter. It really does matter. You are directed which point to start at, and it does impact your answer. Okay, partition point. All right, here we go. Good. So we're using that same formula up here, and all I'm doing is copying this formula down here, and we determined that they're saying from A to B. So yeah, our starting point is A. So therefore, let's label. Really important that you do this. Don't just try to do this in your head. Write it down carefully. I gave you enough room to be able to do it. So this is what I do at least. I put a 1 there. That's my starting point. Point A is my starting point. So therefore, 4 is going to be x1. And what this means is this is the x-coordinate of point 1. So that subscript tells us that this is the x-coordinate for point 1. And then 6 is going to be y1. That is the y-coordinate for point 1. Okay. And then the other point, the ending point, is x sub 2 and y sub 2. So these are the x and y coordinates for the ending point. So the rest of it is just plug it in. Piece of cake, man. So here we go, x1. So here's our starting point, plus what fraction of the whole are they wanting us to go? What fraction of the whole do they want us to go? So we start at 4, and then we add, we plus what fraction of the whole. So the fraction, our scale factor, is 1/2. And then how do we determine the whole? We take the ending point. So here we take our ending point. Let's do it this way. Here's our ending point, and then we subtract the starting point from that. Okay, so the ending point was this x sub 2. Be careful, don't grab the y coordinates, just the x. The x coordinate, x sub 2, minus, and then the starting point for the x coordinate, x1, which is 4. Okay, be slow on this. These are negative numbers. Remember, negative numbers are like razor blades. They'll cut you. So 0 minus 4 is negative 4. And then, so now we have a fraction times an integer. I would recommend take that off to the side so you can remind yourself how to do that carefully. And so remember, to multiply a fraction times an integer, you need to turn this integer into a fraction. So you do that by putting a 1 underneath that, and then multiply straight across the top, and then straight across the bottom. So 1 times 4 gives you 4, and then 2 times 1 gives you 2. And then you can reduce that fraction, either by saying 4 divided by 2 equals 2, or you could say you have a greatest common factor of 2, so divide top and bottom by 2. All right, now you bring the 2 over, but remember, be careful with signs. So here we have a positive times a negative. Positive times a negative gives us a negative. So be real careful to not lose track of that sign. And then 4 minus 2 gives you 2. Okay, so that is the x-coordinate of the partition point. The x-coordinate of the partition point. So that's a nice answer, but that's only half the problem. Woo! So how do we find the y-coordinate? Well, same way, really. Here is the formula for doing the y-coordinate. Again, remember, these are exactly the same. You just swap out the y's, take out the x's, and put in the y's. And so this is your job. You're going to go and plug in these things. Remember, it's the same scale factor for this one as for the x-coordinate. Okay, are you good enough? So go ahead and pause the video. You do this on your own. You do that one on your own. And let me give you a hint. The answer for the y-coordinate is 3. So go ahead and do this on your own. Did you do it on your own? Okay. I'll trust that you did. And so again, remember that you should get y sub p equals 3. That should be your answer for the right-hand side. And you take that 3 and you combine it with the x-coordinate for the partition point, and this is your answer. So 2 comma 3 is your, you could say it, that's your xp comma yp is your answer, 2 comma 3. Okay. Let me give you a little bit of a hint for these other ones. You're going to do these on your own. And so if you want to pause the video and just use this on your own, then you can do that, because there's not really much beyond just what I have written there. All that should be sufficient for you. So go ahead and do that on your own. And so now you've done that. I'm not going to tell you the answer. You have to do this one on your own. And then number 5, do that dude on your own also. And number 6, be careful. There's a little bit of a trick going on here with number 6. So walk very carefully. And this, remember, make sure that you're looking at the ratio very carefully. And make sure that you're looking at the starting point. See me winking? Make sure you look at the starting point very carefully when you're doing all of these, but especially when you're doing number 6. All right, that should be good enough. Hope this is helpful to you. and we'll see you in class real soon.